An object is thrown from a height of 100 feet, and its position is given by the equation y equals negative 16x squared plus 64x plus 100. A. How long will it take for the object to reach its maximum height? B. What is the maximum height? To solve this problem, we must first power up the calculator by hitting the power button, the on button, which is on the bottom left part of your keypad. Then we have to enter the position function by going to y equals, which is located on the top left. At this point, you must type in the position function. Negative, and make sure you put the negative, use the negative key, which is on the bottom row of your keypad. 16x, hit the x squared key, plus 64x plus 100. Usually we graph this in the standard mode, which is found by pressing the zoom key in the top middle row and hitting item number 6, which is zoom standard. However, this gives us something which is almost impossible to deal with, and that's because we must take a closer look at the problem. If you consider the problem with the equation given, we know that x is time and the position y is in feet. Certainly, we're starting at 0 seconds. We're not talking about negative time. And the position function is at least 100 feet high, ground level being 0. So press the window key, which is in the top row of your calculator, second button from the left. And we're going to adjust the time intervals. We're going to start at t equals 0 or x equals 0. So I simply type 0 at x min. And because I've done this problem, I know that certainly within 6 seconds the object will indeed hit the ground. If I didn't know that, I could always adjust it as I'm doing the problem. Y min is the minimum distance. The minimum distance would be ground level, which is y equals 0. We already know that it's starting from a height of 100 feet. Let's assume that it goes up at possibly another 100, and we'll make that 200 feet for y max. What we have done now is change from a standard window to this window, which reflects the parts of the problem that we're concerned with. If I now press graph, which is the top right button of the screen, I see a simulation of the object in motion. The maximum height appears to be right about over here, and that's the height that I'm interested in. I'm interested in how long it takes to reach the maximum height. That would be the x value, and the maximum height, which would actually be the y value. To do that, we can use the calculate function of this calculator. Press the second function key and trace, which now becomes second calculate. If you look at your options, you'll notice that option number 4 is maximum. So we'll press 4 for maximum. You should always look at the prompts on the bottom of the screen. It asks for the left bound. By using the left arrow key located in this portion of your calculator, you move to the left of that uppermost point and hit enter. By hitting enter, it puts a marker near that point so you can see exactly where you are. Now it wants the right bound. Using the right arrow key, move to the right of that point. Again, pressing enter means that you've accepted those parameters. You now want, again, that uppermost point, and the calculator wants a guess. They don't expect you to type in any numbers. They are simply allowing you to get closer to that point, which you don't really have to do if you don't wish to. I did, and I'm pressing enter. If you look on the bottom of the screen, you'll see a number which is not exact, but that is due to the limited capabilities of any calculator. And certainly we can deduce that this number is actually x equals 2, and that's how long it took to reach the maximum height, indicated by that cursor over here. So it took 2 seconds, And by looking at the y value, which gives me the position, it indicates that the maximum position of that object in motion was 164 feet. Keep in mind that this is truly a calculus problem that could be done using calculus, but however, the graphing calculator is a nice tool in simulating the object in motion and arriving with the same result.